Hello and welcome to lesson 1 of our problem solving unit. We're going to use the algebra we've learned in our previous units to solve word problems. You can print the notes sheet and work on it as I work through the questions. Let's start with this one. All the word problems will give information. Some of it will be useful and some of it will be extraneous. They will all have an unknown number, or possibly two, that we have to find. The first thing you have to decide is what we are looking to find. Fortunately, it's usually really clear what number we're looking for. We call the unknown number we're trying to find the unknown. Very creative, eh? In example 1 here, it's quite clear. The question says, find the number, after giving us a bunch of information about that number. We have to translate this information into an algebraic equation, and then we have to solve it. Let's look at this one. If a number is doubled, and the result increased by 4, the sum is 94. We have to find that number. Whenever a question says if a number, or there is a number, or this kind of thing, we use a letter to represent this unknown number. You'll see your teachers use a lot of X's and Y's, but this is just a force of habit. I encourage you to use a letter that helps you remember the characteristic of this unknown number. In this case, I'm going to use N in order to stand for the unknown number. So it says, if a number, we'll call this N. I'd encourage you to use the form you learned in about grade 7, where you set up the question by starting with a statement that defines your unknown number. In this case, it's a single number. So I'm going to say, let N equal, do a little space here, so let N equal the unknown number. That'll help us later when we're solving things. So now we have if a number N is doubled. All right, so to double number, we're going to multiply it by 2. So we have 2N. And the result is increased by 4. Increase, you can tell, is addition. We're going to increase that by 4. The sum is 94. Whenever you see is in one of these problems, that's an equal sign. So we're going to have equals 94. Now you'll find the actual algebra we have to do for these problems is much easier than the algebra you did during our algebra unit. And so you should have no problem with this. Let's subtract 4 from both sides. So we have 2n equals 90. Now, since 2n means 2 times n, we're going to divide both sides by 2. And we're left with our answer. N equals 45. The beauty of this unit is we can check all our answers. We said the number n was 45, so let's check that. We say when 45 is doubled, so that'll give us 90. And the result is increased by 4, so that will give us 94. The sum is 94. And so we must have done it properly. Everything's working out beautifully. Now we always finish a word problem with a sentence answer. So we should say the number is 45. And we're done. Let's try another one. You have a read through and think about this one, and then I'll start. You can pause the video to have a think about it. The larger of two numbers is 7 more than 5 times the smaller. If their sum is 61, what are the numbers? All right, so here's one where the let statements at the beginning become very useful. We've got 2 numbers here. So I would write down let L equal the larger number. And then we could say something like let S equal the smaller number, but my S's look a lot like 5s and it's confusing. So I think I'll just put n again. So let n equal the smaller number. And if you do this at the beginning of your questions, then it'll really help you at the end, especially with the more complicated questions. All right, now we can read through it, and we actually have two relationships in this one. So the larger of two numbers is 7 more than 5 times the smaller. Okay, so what we have is there again. The larger of two numbers, we said the larger was L, is, there's our equals, 7 more than 5 times the smaller. So I would put 5n plus 7. Remember that the 5 and the n side by side means 5 times the n. Okay, so that's 5 times n, and then 7 more. Okay, so that's one relationship. That doesn't look like that's going to help us much because there's two variables to solve for, and there's only one equation. So we've got some more information. If their sum is 61, all right, so then we have L plus n is 61 equals again, equals 61. All right, so again we have an equation with two variables. Can you see, can you have a look at it and see what we could do here, what we could substitute to give us an equation with just one variable to solve? And it sits right here. We said L equals this, 5n plus 7. So let's substitute that in for L, if that's what L equals. And we get this, 5n plus 7 plus n equals 61. Using two equations like this is usually called a system of equations. Now you can see I've just got n's to solve for. I can just collect them up, isolate the n, and I'll have my solution. All right. You can see I would get 6n plus 7 equals 61. Let's subtract 7 from both sides. 6n equals 54. And then we would divide both sides by 6 to isolate the n. We've got n equals 9. Now, since we have two values to solve for, we're going to have to take this value and substitute it back into one of our equations to find the other value, the L. I would go up here. L equals 5 times n, and we said n was 9. 5 times 9 plus 7. And so we get L equals 45 plus 7. We get L equals 52. Now we should check that. We should check that these all work. We can see that if n is 9, L is 52, and then L plus n we're supposed to equal 61. 52 plus 9 does equal 61, and so we know we've done everything correctly. So I need to put a box around them, and then since it's a word problem, we have to finish off with a sentence answer. The larger number is 52, and the smaller number is 9. And we've done that one. Let's do a couple more together. Here's one for you to try. Pause the video, see if you can set it up. The key to this one is 3 consecutive numbers. See if you can come up with a good plan for setting up those consecutive numbers. Here's what I do to set up consecutive numbers. I'm going to say let n equal the first number. Well, a consecutive number is just one more than the previous number. So let's say this. Let n plus 1 equal the second number. And then of course we want 3 consecutive numbers, so then let's say let n plus 2 equal the third number. And so now you can see we don't know what these numbers are. They're unknown, but we do have 3 consecutive numbers here. All right? So the sum of 3 consecutive numbers is 33. So the sum of these 3 numbers, n plus 1 plus n plus 2, equals 33. And you can see by setting up these let statements, we've organized very well and given ourselves quite a simple algebraic equation to solve. Let's collect things up. You can see if we collect up like terms, we get 3n plus 3 equals 33. Subtract 3 from both sides in order to isolate that n. 3n equals 30. And then divide by 3. n equals 10. We've got our solution. Let's check to make sure, and then we can write our sentence answer. So if n was 10, that was the first number. The second number was 10 plus 1, and the third number was 10 plus 2, and the sum, 11 of course is 10 plus 1, and 12 is 10 plus 2, and the sum of these 3 numbers was 33. And you can see that 10 plus 11 plus 12 is 33. So we've done it correctly. Let's write out our sentence. This is also where the let statements help. They help us writing out our sentence answer. The 3 consecutive numbers, the 3 consecutive numbers are 10, 11, and 12. All right, that's probably long enough. There's one more example here. Have a look at it, pause the video, see if you can do it, and I'll add the answer in just a second.